Okay, so yesterday we discussed something about sets and neighborhoods, right?
Yes.
Okay, so we discussed two types of set and we did comparative study of these two sets, right? So, for example, uh, what we discussed, if set A is equal to interval 0 1, right? So interval 0 1 means those real numbers for which 0 less than x less than 1. Now for this set what we found, for every delta, the delta neighborhood of one intersection with A is non-empty, right? For any delta, deleted delta neighborhood of one intersection with A is also non-empty. Do you understand this? Is it clear? For any delta,
Yes.
so deleted delta neighborhood of 0 intersection with A is non-empty, right? For any y belongs to 0 1, right? For any y belongs to 0 1, so v delta y intersection A is non-empty for every delta. So what is the moral of this story? If you look at interval A as a interval 0 1, right? So if you look at this set 0 1 and you choose any point, for example if I choose 1 and if you draw any neighborhood around that one, that neighborhood always intersects with set A, right? Our set is interval 0 1. So you, if you take any neighborhood around 1, it always intersect, or you take any neighborhood around 0, it always intersect with A, or you choose any other point y and you take any neighborhood around y, that always intersect with set A. This is what the very simple observation. Second point, if my set B is 1 2 3, so this is finite set 1 2 3 4 or whatever 3 element set for example, then what we found ki v delta 1 intersection with A is single point, right? If delta is less than 1, but v delta intersection with A, so deleted neighborhood of 1 intersection with A is empty. Is it correct?
Yes.
Right. Similarly, v delta dash of 2 intersection with A is empty if delta is less than 1, and same is true for 3, right? So this is a observation for this set. And so what is the difference between these two sets A and B? What is the difference? Ki if you take deleted neighborhood of a point, right? So if you choose any y, for any y, right? If you choose any real number y, v delta dash y intersection with A is always empty, provided your delta is very small, right? Right. So
Yes.
for small delta, right? So if you choose smaller delta and then you look at the neighborhood, deleted neighborhood of y, then intersection with A is always empty. So this is main point. Okay, so from this we are going to make a definition. So let A be a subset of R and A is non-empty, right? A is a subset of R and A is non-empty. A real number C is said to be a cluster point. So please keep your mic off. Gitika, keep your mic off. Okay. So a real number C is said to be a cluster point of set A, right? Cluster point of set A if it some condition is satisfied. If so, a point is a cluster point of set means it is very close to that set. If for any delta, for any delta V delta dash C intersection with A should be non-empty, right? So is definition clear? Is definition
Yes.
clear? So, so you should keep your mic off even you are not talking with me, right? Some people just keep the mic off and it create disturbance. So you have to take care of these things. So a point is a cluster point means what? For any delta, whatever delta you take, if you take neighborhood around that point of any radius delta, it should be overlapping with set A. Then such point is called as a cluster point of set. Right. So for example, that is C is a cluster point of set A if every neighborhood, every deleted neighborhood of C overlaps with or intersect with A. Right. So, for example, let us think about simple case as we discussed yesterday. A is a set of those real numbers for which right or interval 0 to 1. Now question I would like to ask, first question is C is equal to 0 cluster point. Cluster point of A. What is your answer?
Yes, sir.
Yes. Right? Do you understand? Everybody understand what I am saying? Ki cluster point means what? For any delta. For any delta, if you draw neighborhood around that, it should be overlapping with set, right? And if you look at 0, you take any uh, neighborhood of 0, it is overlapping with set A, right? Any small neighborhood, whatever delta smaller may be, doesn't matter. So answer is yes. Now next question is C is equal to 1, a cluster point
Yes, sir.
of A. Answer is Yes, right, it should be overlapping. That means for any delta v delta dash 1 intersection with A is non-empty, right? So whatever delta you select, you can always find a neighborhood. You can always find, that means, for example, if I take V half 1 intersection with A, is it empty or non-empty?
Non-empty.
Non-empty.
Non-empty, right? Because what is the element which is in this intersection? If you, when we say something is non-empty, that means can you produce at least one member which is in intersection, right? So what is V half 1? What is half neighborhood of 1? What is half neighborhood of 1?
The half to 3 by 2 instead of 1
Right.
means leaving 1.
Up to 3 by 2. But in intersection, which part will be there? So this part, right? So, so this part will be in the intersection. And can you produce at least one member which is in the intersection?
Yes, sir.
Right. So, so because why this is non-empty? Because the simplest candidate which is we can see is 3 by 4. It is in V half dash 1 intersection with A. So at least one member is there. So certainly it is non-empty. In fact, there are many members. Right. So next question I would like to ask is half a cluster point of A?
Yes, sir.
Right, very good. So half. Now my next question is what are all cluster points of A? Can you give me all the cluster points? And what is answer?
0 to 1.
Right? Answer
0.
is uh, 0 less equal x less equal 1, because 0 and 1 are also cluster points even. So note that 0 is not member of A, but 0 is a cluster point of A. So this is important point. So a point, a cluster point of a set may not be a member of set. May or, right? Because for example, half is a member of set and is also cluster point. So right. So the sentence, this last sentence is clear. A cluster point may be or may not be member of a set, right?
Yes, sir.
Okay. So now you understand what is a cluster point of this. Now next example. So let A is equal to 1, 2, 3. Right. So this set. Okay. So question I would like to ask is 1 a cluster point?
No, sir.
No. Why?
B dash is empty.
Okay, so why? So yesterday we spent some time on this. For example, if I look at V2 dash 1, what is V2 dash 1?
It's empty.
No, V2 dash 1 is what?
So it includes
1 minus 2 to 1 union 1 to 1 plus 2, right? I am looking at two neighborhood of 1, 1 minus 2 and 1 plus 2, and except 1, I am neglecting 1. So, okay.
yes.
First of all, what is uh, V21? V21 is minus 1 to 3, and I am deleting 1. So, it is minus 1 to 1 union 1 to 3. Now V2 dash intersection with 1, V2 dash 1 intersection with A, what is it?
Empty.
Three.
See, 1,
So it
2,
includes 2.
3, and I am looking at the 2 neighborhood, means my radius of neighborhood is 2. It is extended up to this, right? And on left side it is minus 1. So what is 2 neighborhood of 1 is minus 1 to 3, and in that 2 is there. Okay, I am neglecting 1.
Yes.
So certainly 2 is there. I am not neglecting. Right. Now what is V2? What is V1 dash 1 intersection with A? Now I am looking at one neighborhood. It is from 0 to 2. And what is common with A? What is in common with A?
And so nothing, it's empty.
It is empty. In fact, V delta dash of 1 intersection with A is empty for every delta less than 1, right? For every delta, if you take radius delta smaller than 1, it is, and therefore is 1 a cluster point? Because what is the definition of cluster point says? The definition says that for every delta this should be non-empty. Is it non-empty for every delta?
No, sir.
No, right? For some delta it is non-empty, it is non-empty, but for some delta it is empty, right? So therefore, hence 1 is not a cluster point of A. So this is clear. Now next question is 2 a cluster point of A?
No,
Yes?
sir.
No. Now you understand, same reason. And so what is my set here? I am repeating this again and again because this is not easy at first. So 1, 2 and 3. This is my set. Only 3 points. In between is not in the set. And cluster means some point is a cluster point of a set, means near that point there is a cluster of elements of set. Near that point there is a cluster of elements of set. Cluster means crowd. Cluster is crowd. Do you understand? And so near 1, is there a cluster of elements of set A? Right? So no cluster. But if you, on the other hand, if you look at interval 0 1 and if you look at 1, is there a crowd of elements of set near 1?
Yes,
Yes.
sir.
Right, because if you go on left side of 1, there is a crowd of elements, cluster. Same thing for 0, same thing for half, same thing for 1 by 3 and so on. So every point in between, so there is a cluster near. But in case of set A, if you look at 1, there is no crowd near 1 of elements from set, so no cluster, right? This is a very simple way to understand what is the meaning of cluster points. So, right? Question 3, is 3 a cluster point? of A?
No, sir.
No. Right? And now my final next question, is half a cluster point?
No.
Of course no. Right? And last question, what is the set of all cluster points of A? Can you tell me what is the set of all cluster points of set A?
So it's empty.
Empty. Right. And what is the moral of the story? What is the conclusion? Set A is equal to 1, 2, 3 does not have cluster point. Right, and therefore a set may not have a cluster points because it is not necessary that every set has a cluster points. A set cluster point at all. Right? Do you understand this? Okay, so let A is equal to interval 0 to infinity. 0 to infinity means real numbers for which are greater than 0. All real numbers greater than 0. So what are the cluster points? So what are cluster points of A? Yes.
So closed interval 0, then infinity open interval.
Right. Very good. So is minus 0.01 cluster point?
No, sir.
Of A. So answer is no. Right, because there is no crowd of elements from set A near this point, because if you look at 0 here and minus 0.01 is on left side, right, minus 0.01 is on left side of 0. So this element is somewhere here, right, minus 0.01, and there is a gap, right, there is a gap, and so there are neighborhoods, there is a delta for which the neighborhood is not overlapping with set, that we can easily see, right? Correct.
Yes, sir.
Okay, and therefore, so I can make a definition, let a subset of R a point which is a point C belongs to A is said to be isolated. An isolated point of A if it is not cluster point. Of A, right? So now you understand कि isolated points means it is not a cluster point. So for example, for A is equal to 1, 2, 3, every member is isolated. Do you see it? And you can understand because there is a separation, right? Right?
Yes.
And if you look at interval, then no isolated points. So Of course you can. Now there is a very interesting example. Let a is equal to 1 by n. So look at this set. N is natural number. Now the question is, now do you understand what is this set?
Yes, sir.
So what are the members? 1, 1 by 2, 1 by 3 and so on. These are members. Right. So if you look at this members, what is my first member? 1. What is my second member? Half. Right. What is my third member?
1/3.
Right. 1 by 4 and so on. These are all the members. Okay. So question I would like to ask is 0 belongs to A?
No, sir.
Right. Answer is no. Very good. Fine. Now next question is 1.
Sir, one
Yes.
doubt.
Yes.
Sir, if 1 by infinity is there, then it will be 0.
Infinity is not a natural number. Is infinity a real number?
No, sir.
No. And what are the elements of set? Elements of sets are constructed using natural numbers. But infinity is not available in natural numbers. We cannot construct 1 by infinity. Yes.
Yes, sir.
Your doubt is clear?
Yes, sir.
Okay, fine. See, whatever, why we call the numbers as a real number, because these numbers, you choose any real number, it is in our control. And what is the beyond universe, which is not in our control, which is beyond the real numbers, called as infinity. Right. So real line, you take any real number, whatever bigger it may be, it is under our control. And which is not in our control means which is outside the real numbers is infinity. So when we say infinity, it is not in real numbers. So of course it is not in natural numbers. So we cannot produce 0. Point is 1 a cluster point of A? Yes.
No, sir.
What is your answer? No.
No.
Right, so everybody understood this because it is, and we can see easily it is isolated. There is a gap. There is no crowd of elements from set near 1. There is no crowd that we can see easily. Or I can produce. What is the reason? V 1 by 4, 1 intersection with A is empty. That means if I take a neighborhood of radius 1 by 4, deleted neighborhood of 1 and its intersection with A is clearly empty. Because for cluster point, every neighborhood should overlap. But 1 by 4 neighborhood doesn't overlap. So, not cluster point. Okay. Is 1 by 2 a cluster point?
No, sir.
Right, so answer is no. Very good. Okay. Now, is 1 upon 100 a cluster point?
No, sir.
No.
No, sir.
Same reason, because if you look at 1 by 100 and 1 upon 101, since even the space between these two numbers is very less, but there is a space. And as a mathematics student, a very small space can be a big space for us because we can produce many numbers between them. Right. So there is a big gap between 1 upon 100 and 1 upon 101. So isolation is there. Right. Is 1 upon 2021 is a cluster point?
No, sir.
Sir.
Okay, so answer is of course no. Same reason. Now the next question, does there exist y belongs to A such that y is a cluster point?
No, sir.
No, right?
Sir.
So can you produce any member of a set which is a cluster point of A? Right? And answer is no. And what is the reason? If you look at any member for let y belongs to A, right? Then what is y? Y is 1 upon n for some natural number n, some natural number n, right? Because what are the members of A? Members are of the type 1 upon some natural number. So when I say y is a member of A, that means of course y is element of this type 1 upon n for some number, right? And therefore if you look at 1 upon n, then what is the previous one, previous number, and what is the next number? Yes, previous one is 1 upon n minus 1. What is the next number of y? Right, what is the number which appears next to y is 1 upon n plus 1. Do you understand this?
Yes, sir.
Right, do you see the figure? I have drawn some figure.
Yes, sir.
Right, now you can tell me, is y cluster point?
No.
No, clearly it is isolated because I can produce a neighborhood which doesn't overlap with set. Right, now you just find out what is delta. What is the choice or what is the value of delta such that v delta dash, right, y intersection with A is empty. So you just find out. It's a very interesting exercise. What is a proper delta? That neighborhood, delta neighborhood doesn't overlap with it, delete it. So, and therefore no point, no member of set is a cluster point. Now my question is, does A has any cluster point?
Yes, sir.
Right, so no member from set is a cluster point, but does there exist any other cluster point outside the set?
Yes, sir.
Yes. What is that?
0.
Okay, so prove that. 0 is a cluster point of A. Right? So prove that 0 is a cluster point of A. So how will you prove it? So what is our aim? 0 is a cluster point of A, right? So this is our aim. Fine. Okay, how to do this? So what we want, right? We want to prove that some point is a cluster point, means basically by definition what we expect, what we want, what we wish to prove. Yes.
Delta neighborhood of 0, deleted neighborhood of 0, intersection A is non-empty.
Right. For any delta V delta 0 intersection with A is non-empty. This is our aim. Right. But here 0 is not member of set, so you can say delta neighborhood or deleted, same thing. Right. That is what we expect. There exists x in A such that V delta 0 intersection, so x is member of this intersection. That is, there exists x in A such that x belongs to V delta 0 and x is in A. Right. That means for any delta, whatever smaller delta, one can choose delta is equal to half, then it must be true. or if you say delta is equal to 1 upon 5000, then it should be true, or if delta is equal to 10 raised to minus 1 crore or 10,000. So delta is equal to 10 raised to minus 10,000 is a very small number, right? And when I look at delta neighborhood of 0, so 0 plus delta and 0 minor delta means minor delta to delta. If delta is very small, then this neighborhood is very small. Still it overlaps with A, that we want to check. And how will you produce that? So given delta, right? Suppose you say that 0 is a cluster point of A. Somebody will ask you prove it. So the second person will ask, he will give you very small delta, and then you have to produce a member, right? Here you have to produce member here which is in A, right? So if you produce member which is in the delta neighborhood as well as in A, that means it is here, somewhere here. That means it is in the intersection, right? Do you see the figure? Yes. So how to start the process? Given delta, right? कुछ भी delta हो, we are able to find point in the neighborhood as well as in A which is in common given delta. So what we want now, x is in V delta 0 intersection with A. I am not saying deleted because 0 is anyway not in the member of set. So no question about 0. Anyway, now given delta, now can you tell me what is the point? Can you produce such point?
Yes, sir.
So how? Because x is a member of A, that means x is of the type 1 by n. So what basically I expect? Expect x is in A and x is here. That means x is some 1 by n naught or some n naught because x is member of A. And can I produce some 1 upon n naught which is in between 0 and delta? Is it possible?
Yes, sir.
And what is the guarantee that there is such n naught such that 1 upon n naught is in this range?
Sir, Archimedes.
Archimedean property.
Very good, right? So by Archimedean property, there exists natural number which is greater than 1 by delta, right? So there exists natural number n naught such that 1 up n naught is greater than 1 by delta. So ultimately what happens, right? But x is equal to 1 upon n naught is a member of set because all such numbers are in set A, and since 1 upon n naught is in between 0 and delta, therefore x also x is equal to 1 upon n naught, right, is a member of minor delta to delta which is what, V delta 0, right? Therefore x is equal to 1 upon n naught is a member of V delta 0 intersection with A, and hence V delta 0 intersection with A is non-empty, right? Is it true for any delta?
Yes, sir.
Right, so whatever smaller delta you select, I can produce n, right? Hence 0 is a cluster point of A, right? Can I say it is the cluster point?
Yes, sir.
right? Moreover, 0 is the cluster point. Right, it is unique because this set has only one cluster point. Now the idea is clear. Idea is clear.
Yes, sir.
Right. So A is equal to, for example, x such that, or, so what are cluster points? Now you just think over it. That is exercise. And then very basic question, why we are talking about cluster points? So why we are talking about cluster point? And reason is, so when we talk about limit of a function at a point A, then as x approaches A, right, f of x approaches some number L, but what is the guarantee that we can approach A, right? Suppose A is subset of R and f from A to R is a function, right? Suppose my function is defined at A, so as x tends to A, approaches A, we can think about where does f of x approach, right? So as x approaches A, we can think about where does f of x approach, where value approach, right? But what is the problem in general? So my set is suppose A, right? This is my set A, and this is my point A, and this is my function, graph of function. Now as x approaches A, that means x is here, then f of x is here. If x is here, f of x is here, and as x becomes closer and closer, then f of x tends to some number, that is a limit, right? But when we say x approaches A, that means at the instant when I say limit x tends to A, when I say this, means where is x at this instant? Do you understand? Where is x at this instant? When I am saying x tends to A, that means at this instant x is tending to A, but at this instant where is x?
In the neighborhood of A.
Very good. So at this moment x is near A. Near A means in the neighborhood of A. And therefore if x is near A, then what does it mean? What does the f of x make sense?
That it is a neighborhood of some other number.
Yes. So when I say x approaches A, that means at this instant x is near A. But in that case f of x makes sense if near A function is defined. Right?
Yes, sir.
Makes sense if f is defined near A. F is defined near A means what? That is, if A is, F is defined near A means the,
Cluster point.
so the nearby part of A is a part of domain. That means A is a cluster point of domain of F, right? If your domain of F is this set A, domain of function is this set A, and you take any point A, then near a function is defined, then certainly we can say that A is a cluster point of A and we can approach. X can approach A because X is near A, then f of X makes sense. The idea is clear why we are talking about cluster point?
Yes, sir.
Right. Fine. So technically this should be clear key when we talk about limit, then at what point we are talking about. So for example, my set A is interval 0 1, right, union 2, and f from A to R is a function, right? Now question, can we discuss limit of f at 1? What is your answer?
Yes, sir.
Yes. And what is the reason?
1 is a cluster point of A.
Right, 1 is a cluster point of domain of function, right? And near, see, domain of this function is 0 to 1 and 2 is some isolated point. 2 is also member of set, but 1 to 2 part is not in the set. But we can discuss limit of f at 1 because there is a way to approach 1 in the domain, right? There is a way to approach 1 through the domain, right? Suppose you are at some island and can you reach that island, right? So if there is a way, there is a path, then you can reach that island. So same thing, isolated. Okay, so can we talk about limit of f at half? Can we talk about limit of f at half?
Yes, sir.
Yes, right? Same thing. But can we talk about limit of f at 2?
No, sir.
No, because there is no way to approach 2, because 2 is isolated point, right? And therefore even your point may be in the domain, may not be in the domain of function. We can talk about the limit, we may not be able to talk about the limit depending on the whether it is a cluster point. So 1 is not member of set, but still we can talk about limit, right? Okay, then what is limit? Then big question. Right, so what is the limit of function at a point? Right, and it is somehow similar to the limit of sequence of numbers, limit of sequences of numbers. Okay, I will give you example. Uh, suppose we are talking about function from A to R and C is a real number, and we want to talk about what is limit of function at C. Right, when I say C is a real number, what does it mean? C is a real number, what does it mean?
C is a cluster point of domain of function.
We are saying that will be assuming that C is a cluster point of domain A. C may be member of set, may not be member of set. When I say C is a real number, means it may be inside A or may not be. That is not an issue. What is the important point? It is whether it a cluster point. That is important issue. Right. So, okay. So this is my point C, and this is my graph of function. And now I want to discuss the limit. That means, so x is here, then f of x is here, corresponding value on y axis, right? Right, suppose x is more closer, then where is f of x1? Still closer, right? On this side or that side, doesn't matter. If my x3 is here, then f of x3 is here. That means if I go closer and closer to see ultimately where f of x is going, f of x is going towards some number L, right? Then I say that key as x tends to c, f of x approaches L, and therefore limit of function at c is L. So this is what I want or I expect, correct? But what is a classical or most modern definition of limit? Right. This is just simple rough observation ki as x approaches c, then f of x approaches some number. But what is a technical, more classical? Because every time you will not be able to draw the graph of a function. Right. Sometimes it is very difficult to sketch the graph and see the graph easily and predict what is the limit. Most of the times it is very difficult. Right. So, what is the definition or what is the criteria to prove some number is a limit or find the limit, that we are going to discuss, right? But what is the criteria? What is the technical definition? So, for example, same example which we discussed while talking about limit of sequences. Do you remember? Suppose some person, so my set is set of real numbers, and my variable, what is f of t? Suppose some person want, you are going from Pune to Mumbai, right? Right, so you are going from Pune to Mumbai, you are here and you have started, and this is a final destination M, final destination, right? So how will you prove that you are going towards Mumbai? Because our aim is f of x is tending towards limit L as x tends to C. F of x tends to L as x tends to C. This is our aim. Suppose time required from Pune to Mumbai is suppose 120 minutes. To reach is 120 minutes. Right? Suppose time required is 120 minutes, 2 hours. And therefore, what is my domain of function? I will start from 0 and 120 minutes. 0 minutes I am in Pune, and at 120th minute I should be at Mumbai. Right. That means what I expect, my function is a position, right? Position on the road, right? Suppose I am at this point at time t, my position is f of t. Do you understand this?
So,
Right. At time t, my position is f of t on the road. So what I expect, ki limit t tends to 120 of f of t should be what? What should be the destination?
Mumbai.
M, right? This is my claim. Suppose you are saying that I am going towards Mumbai, but the other person may not believe. He will ask you prove it. How to prove? Right? And you know that as time t, we are in ideal situation. At 120th minute you should be at Mumbai. At t tends to 120, that time tends to t 120. The position is at exactly at Mumbai central point, right? Okay, so how to prove this? How will you prove this? How will you prove? Suppose some person is asking to prove it. How will you prove it? Yes. So any idea? Yes. See, whatever definition we are going to make is a more technical definition, but the same thing happening in our day-to-day life. Right? Whatever mathematical or technical things we are doing for convenience or mathematical calculations, it is necessary to have some technical language, mathematical language, but the same phenomena takes place in day-to-day life. So, okay, so what you will do? The opposite, the other person will give you some neighborhood. Are you in the neighborhood, this much neighborhood of Mumbai? Are you in 10 kilometers neighborhood of Mumbai? Right? Then what you will do? Suppose he will ask, are you in the 10 kilometers radius from central point Mumbai? What will do? Yes, you will give him a location at some time t. You will give him a location at time t. Okay, at that time check my location. Then at that time you are inside this range. What happens after every time after that? Suppose at time t1 you are in this neighborhood 10 kilometer distance from Mumbai. Then right. Suppose at you are in 10 kilometers from Mumbai at some time. Suppose that time is we how many minutes? 100 minutes suppose, right? T is equal to 100. At 100 minute you are in this range 10 kilometers. Where will be at T is equal to 101?
So more closer to Mumbai.
Yes. You certainly you are in this inside the 10 kilometers,
Yes, sir.
right? That means for every T greater equal 100, you are in 10 kilometers range. That should happen. Otherwise, what will happen? You will give him the 10 t is equal to 100, and you are in 10 kilometers. That is not sufficient. That means you may take U-turn and come back after that location. Right? That should not happen. That means for every t greater equal 100, you are in 10 kilometers range. After every t, right? But it may happen that you are at 10-kilometer distance at 100 minutes and you stop there. You are we are inside 10-kilometer range at 100 minutes and you will stop there. That means after every t, for every t greater equal 100, you are in 10 kilometers if you stop at that point, right? Does it mean that you are reaching towards Mumbai? Right? It doesn't mean that you are going towards Mumbai because you have stopped at some point, and it says that for a t greater than 100, every time you are in the 10-kilometer range, but you are not moving forward. How will you reach the Mumbai? Okay, therefore the other person is not satisfied with this. What will get? He will give you some smaller neighborhood. He will give you smaller neighborhood, 5 kilometers. Then he will say that he show that you are in 5 kilometers. Then you will tell him the time t is equal to 115, and after every t greater equal 115 you are in 10. But that is also not sufficient because you may stop after that. then he will give you very small neighborhood. When the person will believe, when the person will believe. Yes.
So can I guess any neighborhood near M?
Ah,
We prove
for
that
every distance, for every epsilon, there exists delta and something happens. Do you realize what we are going to make now? What definition we are going to make?
yes, sir.
Right, and in this way we are going to make the definition. So I think our time is over, so we should stop here. So tomorrow we'll define the